I got a few minutes before parents come in here for parent-teacher conference. So let's do what I can do. I left a note on the door, said come back in 5 minutes. Maybe they'll listen. All right, find the inverse of each matrix. If it exists, do all 2x2s by hand. This is actually a technique I was never taught. I was taught a technique that I don't teach y'all. I'm not hooked up to my little board over here. Let's try it out. Anyways, the idea is that you take your little matrix, you multiply it by another matrix that contains variables. They could be anything in the world. You probably did your notes with W, X, Y, and Z. And it has to equal what we call an identity matrix. And we're going to write a system of equations. This is in row 1, column 1, which means I take this row and I multiply it by that column. So -2, -4 times WY, and I do the dot product, I get -2W minus 4Y, and it has to equal 1. I just write a system of equations. It's pretty quick if you can do this stuff in your head, but if you can't, it's not that quick. This guy is in row 1, column 2. So I'm still taking -2, -4, and I'm going to multiply it by column 2, lost my place, xz, and I would get -2x minus 4z, and in this case it's equal to that 0. We're going to write 4 equations, and we're going to do some substitution techniques and stuff like that. Now I'm at row 2, column 1, so I take 2, 3, multiply it by column 1, W and Y, and I get 2W plus 3Y, in this case equal to a 0. And lastly, I'm in row 2, column 2, so I take 2, 3 again. I take column 2, X and Z, I multiply and I get 2x plus 3z, and I happen to be equal to a 1 here. And then I'm going to do substitution, elimination, lots of good things. Let's see here. Let's take, I'm going to do elimination method because I'm a fan. This has x's and z's. -2x plus, plus minus, wrong button. Okay, there we go. Minus 4z is 0. I'm just going to add down. I get -z is 1, so z is -1. See how that works? And then I can take that z value and I can just throw it right there. So 2x plus 3 -1s is 1. This is -3. Add 3 to both sides, I get 4. And x is 2. So in my matrix over here, I know that that position is a 2. Kind of cool, huh? And I know that my z is a -1, and I'm half done with it. So let's group these w's. I have a 2w plus 3y being nothing, and I have a -2w minus 4y being 1. And I add down, and I get -y equals 1. So it turns out y is also -1. And I plug back in, there's a good place, 2w plus 3 times a -1 is nothing. Shift that over, it's going to become positive. 2w is 3, and w is 3/2. And that's how you write an inverse from an algebraic approach, which I think is probably the most god-awful hard way to do it, to be quite honest with you. But whatever, there it is. The way I was taught was actually to do reduced row echelon form. All right, this is by hand using a determinant approach, which I was also never shown as a kid. I believe the deal is that the inverse of a matrix is -1 over the determinant times the matrix. So I'm going to find the determinant. Now, the determinant of a small 2x2 matrix that contains the elements A, B, C, D is AD minus CB. So here's A and D, 2 times 3 minus the upward diagonal, 4 times the negative 4, and that's going to be 6 plus 16, which is 22. We're going to check and see if I'm right on this, because I have not done this in forever. Anyways, I'm supposed to do negative 1 over the determinant, negative 1 over 22 times this guy, and then I basically do the distributive property. So this would be negative 2 over 22, which is negative 1/11. This would become positive 4 over 22, which is 2/11. This is negative 4 over 22, which is negative 2/11. And this is negative 3 over 22, which is just going to stay negative 3 over 22. Anyways, let's make sure I'm right, because I don't honestly remember doing this. So second matrix, edit. And this is how you check yourself, by the way. You have to do this by hand. Again, we're just spending some time here because Mr. Milbrath doesn't ever remember doing this. It's just a theorem that I've seen. I happen to remember it. So I typed it in, I quit. That was matrix A. I hit the inverse key. I convert back to a fraction. We don't agree, do we? Why don't we agree? Well, that is interesting, isn't it? Did I type it in right? I don't have time to be wrong here. 2, negative 4, 4, 3. Let's pause this, see what I did wrong. See, I'm not infallible. Okay, so I actually remembered the theorem wrong. That might be the problem, huh? That's the theorem. Oops. Anyways, I did the determinant right. It was 22. So what I'm supposed to do is I'm supposed to swap some things around like an idiot. By the way, I hadn't taught you this lesson, so I'll have it fixed by then. So it's going to be 1 over 22. I had some negative symbols in the wrong place. I don't change this. This is what I do. And I swap some components around. Normally it's A, B, C, D. So these two swap positions, 3 and 2. And these guys become negative. So negative 4, positive 4. Oopsie poopsie. Now I do the distributive property, and I get 3 over 22, 4 over 22, which is 2/11, negative 4 over 22, which is negative 2/11, and then 2 over 22, which is 1/11. And let's compare that to the almighty TI-84. And there we go. My loss, your gain, right? All right, 5 and 6 are push some buttons in a calculator. I guess I'll do it. Why not? Because some of y'all don't have calculators. It'd be cool if you did, though. The librarian will give them away. She doesn't give them away. She lets you check them out. I know they're expensive. That's why we do that. They're not as nice as the ones I have in the classroom, but they still do the job. Anywho, I went to second matrix. I scrolled over to edit. Now I'm going to quit out. I'm going to highlight that matrix, second matrix, highlight A, and I'm going to press the inverse key, which is right there on the matrix button. It's right there. And I'm going to convert back to fractions, because otherwise I'd be tempted to round. So to convert to fractions, you press the math key, you press enter twice. And I'm not even sure which number that was. What number did I just do? I was on autopilot, kids, sorry. I did number 5. Cool, that's number 5. Ta-da! Inverse, done. Guys, let's see here. Let's do number 8. This matrix was encoded using that matrix. What is the secret word? All right, so first off, we're going to decode it. What we're going to do is we're going to take the inverse of this thing. And it's going to come first because this is a 2 by 2 and this is a 2 by what? 6? So it has to come first because the inside has to match. So order is a pretty big deal. And we're going to multiply it by that matrix. It's going to take me longer to push buttons than anything. I'll also have to write out A, B, C, D, E, F, G. And that's how I'm going to do it. So I'll need 2 matrices. First one's a 2 by 2. And it has the elements 6, 5, 2, and 2. Quit out. Back to second matrix. Scroll to edit. We're going to put the second matrix in B. And B is a 2 by 6 if I can count, but who knows. And I'm going to type in its elements, hoping I don't make a mistake. I grabbed this from your textbook, so it's probably something happy. They usually are. Probably something about how good math is. I don't know. Or it could be something math related. It might be the word determinant. Seems like I remember doing this problem a year ago. We'll see. So anyways, I typed everything in. I hope there's no typos. I'm going to quit. So the deal is take that first little matrix, find its inverse, and then multiply it by the second matrix, which was B. And here's what I get. I get this. I'm not one of those people who can tell you what number a particular letter of the alphabet is. I'm not that person. I don't know why. It'd be kind of cool if I was, because it'd make problems like this really, really simple, wouldn't it? So I'm just going to do what most people do, and I'm going to write out the alphabet. All right, so the fourth letter, that's D. Let's see, we got 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And we're supposed to read down, by the way. E is 5. 20 is a T. I was right, it was determinant. 13. Sorry, we got another 5, which is an E. Then we're at 18, which is an R. Then we're at 13, lost my place there, which is an M. Determ. 9, which is an I. 14, which is an N. A is 1. 20, I'm sorry, I missed something here. 14 again, which was an N. 20, which is a T. And then 19, which is an S. Determinants. There we go, a mathematical word. And the last one I'm going to do, because it's already 5 after, and there's probably a parent or two out there waiting, is 11. So here's the deal about determinants. The determinant is equal to, for some matrix, A, B, C, D, it's equal to AD minus CB. Now notice I don't even say the word determinant. The bars like this on a matrix, they're not absolute value, it's saying determinant. So I do that, that's negative 2x when I multiply, minus 4x, and it has to equal 7. Put my x's together, negative 6x is 7, divide by negative 6, and x is negative 7/6. And that's how that one works. And that, boys and girls, is your homework for section 10.4. You got to see me make a big mistake, because I'm not perfect. I don't admit that I am, but I don't even try to be. There you go.